Hi, everybody. From Ruth and myself and Isabella, you might be able to see as well. This is our eggs experiment webinar, which we hope to show you lots and lots of little experiments that you can do either at home when you have visitors round for Easter or in your class. Eggs are amazing. Here are some new. These were laid this morning. Look at this. What a beauty. Look at that. Wow. An egg is a living laboratory. There's so much that we don't think about when we eat our eggs. So much versatility in an egg. How many different ways can you use an egg? Not just in cooking, fried, scrambled, poached, but also use the shell in your garden for fertilizer, crunch it up to put the snails off from coming and eating your cabbages and so on. Wonderful. But also, inside, what does an egg consist of? A shell. Inside, there's a white and a yolk. Most people don't think about the yolk. Inside the yolk of a nice fresh egg, there are two parts. Inside the white, there are two parts in the white. If I just take this egg and break it into my frying pan, you can see there. Can you see? I think you can, just about. There's a very thick part. There we can see, thick part here and the thinner part. And I said before, it's like a living laboratory because that will all change with time. The white gets runnier as it changes, it becomes more alkaline. There's so much you can think about within the egg. And the egg also has other bits, two membranes within the egg, just on the outside, and so on and so on. We could talk about an egg for the whole of the webinar, but I'm sure you don't really want me to bore you with that. But it's a good little project to give to children to work out what's going on with the egg. So we've mentioned the different parts. We've mentioned the hen. What a wonderful thing the hen is. Do you know that the hen produces 100 times more reproductive eggs and so on than a human by weight? All sorts of little facts like that that children often like. The egg always comes out blunted end first of the egg. The falls, we'll talk about that later. The air sac forms at the blunt end, and so on and so forth. The eggs are amazing, but you're not interested in chat about eggs. You'd really like to see some experiments. So I'm going to hand over to Ruth to show you just how strong an egg is.
I just wanted to add something that the shell it's very strong, but it's covered with very tiny pores, thousands of pores, and those pores will permit the exchange of oxygen and carbon dioxide between the chick and the outside, and this permits for the chick to develop inside the egg.
Okay, thank you. So, eggs may seem fragile. We know that if I don't have careful, this will be a mess here near my computer. But at the same time, they look very fragile, but they are really, really, really strong. And so I'm going to show you that an egg is really, really powerful. Just going to change my camera. Okay, so you can see here 2 eggs. They are not cooked, so I hope everything goes well with this experiment. And you can see the shape of the egg, this curve, and this is why an egg is so strong. I will talk about later. So I have here a few books. They are really heavy. This is a cookbook with traditional recipes from Portugal. It's really, really heavy. And I'm going to maybe protect this with cardboard just to have a base to put the book on top. And wait a minute. Okay, the eggs are okay. Let's show you. Maybe I'm going to change. Oh, wait. Just camera, just for you to look. Okay, maybe like this. So, eggs, okay. Then another book with 1,000 recipes of bacalhau, so codfish, very traditional in Portugal. And the eggs, I think they are okay. Another one, Jamie Oliver, maybe you know this one. It's also a very heavy book. And I think the eggs are okay. And now I have a very old book from my grandmother, this one. And let's see. Oh my God. Oops. The problem is just the balance. You see? Okay. Let's have a look if the eggs are okay. Yep. They are just perfect. And if you think, is really the egg? Yeah. It's an egg. Probably you know this experiment. And I'm going to explain you. Okay. So this curved structure of the shell will distribute the force applied evenly. So just like an arch in architecture. So when force is applied from above, it spreads across the entire surface, preventing the shell from breaking easily. However, if the force is applied to a small point, like a ring, the shell will crack. So if I do like this, I'm not doing any force now, but if I will do it with this ring, probably the egg will break. So now I have an image to show you where we can see this shape in bridges and in architecture. So this one, and then the next one. Okay, and this one also. You see, this shape in this door is very similar to an egg. And also, in this bridge, you can see the same shape, very similar. So an egg looks very fragile, but it's really strong. Okay. So up to you, David, standing on eggs.
Now, number 2, here we have Charlie, who is about to stand on these eggs. So here we go, Charlie, let's see how you do. There we go, hold your arms up, yay! So the eggs are really very strong. Now, can you get off without breaking them? Yes, you can. Well done, thank you.
So our next activity is putting eggs inside vinegar. What's going to happen? We know that eggshell is made out of calcium carbonate. So we're going to look at this experiment and then I will explain afterwards. Okay, so from this activity, which results can we see? So we know that the eggshell is made out of calcium carbonate, and we know that vinegar is mostly composed of acetic acid. It's an acid. So what happens when we put the egg inside the vinegar? With time, we are going to see little bubbles around the eggshell. That means that a reaction is taking place and carbon dioxide is being expelled. And how can we show this to our students? Or what comparison can we do? We can show them that the egg or the eggshell is similar to our teeth enamel. And if we eat acidic foods, or if we eat food with acid, that acid is going to react with our teeth enamel. So this experiment shows that teeth, when exposed to acidic compounds, the same as the eggshells compared or exposed to vinegar, a reaction will occur. So what we want to tell our children is that if we wash our teeth with toothpaste, and yeah, this is the other experiment, Ruth covered the egg with toothpaste, and we know that toothpaste has fluoride. Fluoride is a substance that's going to protect the eggshell. So the reaction with the vinegar isn't going to be immediate, or it might not occur. So if toothpaste has fluoride, and if fluoride protects the eggshell, the same thing is going to protect with our teeth. So what we want to tell our children is that brushing our teeth with toothpaste is essentially protecting our teeth from acidic foods that we might have in our diet. And everyday food has acid, but the less acid they get inside their mouth, the less tooth damage they'll have. So brushing our teeth is important.
Okay, I have here 3 eggs. This is a normal egg. It's brown. This one is the same egg you saw in the video where we protect with toothpaste, and so it's a little bit more lighter, the color. And this one is the egg that with no protection. Okay. So now, what happens when we remove David? Okay. So what happens when we remove an eggshell using vinegar? So I have here this egg that I put for less than 24 hours, depending on the egg. But this one was a little bit less than 24 hours in the in vinegar, and I will show you what happened. We get this soft, rubbery, and bouncing egg. You can see from high, and the egg will bounce. And also a nice thing, you can look inside of the egg. So I'm just going to turn off the light and show you, maybe with another camera again, I will show you with this flashlight. I hope you can, let me see the best way to show this. I don't know if you can see. Well, with the camera is difficult, but you can see easily the inside of the egg. You see the yolk here. I hope you can see it. If not, we have a picture of this egg. You see? Kids normally really enjoy doing this experiment. And with this, you can explore lots of things. So one of the things is the chemistry of the eggshell with the vinegar, with acetic acid. I think it's this name in English. You also you can say to the kids, okay, look the size of the egg. Let me show you. Look, such a big difference. This one, it's much bigger than this one. Why? This happens because water goes inside of the egg. It's osmosis. And they also can try to calculate how much water go inside of the egg. They can try to have an experiment to measure this quantity of water. We also can do another thing, that it's pick this egg and put inside of a solution with lots and lots of sugar, like could be honey or golden syrup. And what happens is the water is going out of the egg will shrink. And also they can pick up again the same egg and put inside of the water. So kids can experiment this thing. So put the egg inside of different solutions with different quantities of water, of sugar, and see what happens. And you can talk about osmosis. And that's it.
So in fact, just to sort of show you, the eggs, I think on the floor there, just let me hold that. You see the eggs, so it's quite possible to do that. The kids love seeing the eggs, and you can actually stand on them yourself. Right, here's my foot. On 1, on 2, was my weight. I think I cracked 1, but that might be just because I wasn't standing evenly. Or not, but in fact, the one I think I cracked was the hard-boiled egg that I got for later. But all these are fresh eggs from this morning. So the other thing, quickly, which here we have an egg. To balance an egg on its end is almost impossible. Falls over. If you put some salt on the table, it is possible to balance the egg. I got it. I'm trying to do things in a hurry here, but it is possible to balance an egg like that and it stays. The other one, which is a lovely one to do with young children, is with eggs. And you take any sort of beaker there. We put a placemat, shiny side, slippy, on, and then we get some tubes from sweets. We can use anything, big ones or little ones, or even a toilet roll inside. Put them above the beakers, and if you want to use ordinary eggs, fill the beakers with water, and then the eggs don't break. But I'm just using chocolate eggs here because we all have chocolate eggs Easter. I'm not falling on, it's going to fall over. Get it balanced, yes. They're all over. Now I know the children can do this. I've done this with so many children, and the weaker children get great satisfaction from this because so often they can't do something. Let me hold the beakers. I'm going to knock this slippy underneath so it slips away. Rough tubes, very light, so they move out the way, and the eggs fall straight down. Think of the forces into the beakers. Ready? 1, 2, 3. Knocked that one over, but the other two you can see are in the. Oh dear me! It landed on the eggs. At least it shows that the eggs that I was standing on were real. You can see that one that's broken. Another risk coming up. I think we can show the eggs in a vertical circle. No, eggs in inertia is what we're going to do next. Well, it was eggs in a vertical circle. Little trick with some eggs and onto. I would use perhaps an orange or something with this. So I have a frisbee, with fix in the field frisbee, and put some string on, and you put an orange on, and of course you can whirl it round your head, and the orange stays on. So that's one thing you could do with forces. But what about something a little more exciting? An egg, raw egg. Children always like something when there's potential for it to go wrong. So a raw egg, china egg cup, put the egg in, and we can whirl it around our head and nothing comes off. Just be careful when you stop it. But that's a good exercise to work out where the forces are. Can you draw the forces on this as it's going round, as it's, or even just as it swings right and down? So there's another one for you. Okay, so you can use anything. I used some lids from coffee pots, and that works quite well. Pop your egg in an egg cup, and even just looking at the forces as it swings is quite a useful experiment. But of course, this will go around the head as well. Okay, if you take an eggshell, an ordinary eggshell, and put it in water, fill it, and it sinks like that with it sinks, so it goes down that way. But you can, of course, make it go down the other way. And this one floats upside down. You can do whichever way. If you don't show people what's going on, this one will float upside down. There you go. On the other hand, this one will sink to the bottom. And how do you predict that? And do you know what that's to do with? What is that? That's because the egg contains, here's one, an little air sac at the blunt end, which gives the oxygen to the newly born chick, if you get that far with her eggs. So that's another little one you can vary, make it into a puzzle. If you don't tell people there's an air sac there, they don't know what's going on. Okay, over to you, Ruth.
Yes, but Isabel has something to tell before that.
I just wanted to add something to the previous experiment with the vinegar. We all teachers, and we know that vinegar sometimes smells. We can use other ingredients, for example, Coca-Cola or coffee. And normally these two ingredients, they are acids, and they are part of our children's lives. They like beverages. And these two acids will also make a very good experiment, because they're not only acids, but they also staining compounds. So if you put an egg inside Coca-Cola or inside the coffee, the eggshell will absorb the color. And in this case, the eggshell will be a dark brown, and with Coca-Cola it will be even darker. And this will show our children that if we drink Coca-Cola, or if we drink coffee, besides the erosion of the enamel of our teeth, they will also be stained. That's how our teeth will get yellow. So I think it's another type of activity that you can do with your students. Thank you.
And now we go to bad and good eggs.
Bad and good eggs. How can we find the difference between bad and good or fresh eggs? So we know, David explained this earlier, that eggs contain an air cell, and that air cell is at the bottom of the egg. And over time, this air cell will grow over time, because the moisture and the gases will pass through the cell. Remember, I said that the shell contains very tiny pores. And so the more air goes inside that air cell, the older the egg will become. So if we put a cup or a bowl with water, fresh eggs will sink and they will lie flat on the bottom. Slightly older eggs, they will also sink, but they will stand upright. And bad eggs, they will float on top. Why? Because this air cell is full of air, full of gases, so it will rise. And what happens is that bacteria can also grow in bad eggs. What will they produce? They will produce an acid called, not an acid, sorry, a gas, hydrogen sulfide gas, and that's what gives that rotten smell of the egg. But Ruth will show a video of that.
Não, vamos mostrar aqui on live. We're going to show here, live. Okay. So we have here 2 eggs, and I really don't know if they are fresh or not. So this one, let's see. This is tap water. Sinks, so Isabel is...
So it's fresh.
Okay. This one, it's here in the lab for a long, long time. And I think you can see easily that it floats, and floats a lot. So I believe it's
very
really
bad.
Okay, so the question now is, why do some eggs float and other things sink? So is the fact only related to whether they are fresh or rotten? So this one is rotten. I will take this one out. And this one here is, oh, the water is going out. It's fresh. Let me just clean this a little bit. So it's not an experiment. If everything goes well, it's not a good experiment. Okay, so this one, you could see, sinks in tap water. So it's a fresh egg. But I have here also, obrigada, Isabel, thank you. Just clean a little bit. And I have here also water. And this time, let me just put more. Okay. And this time, the same egg floats. So I will do again. Floats here and sinks in here. But it's a fresh egg. So why? This is density. And this water is full of sodium, chloride sodium, sorry, in English, sodium chloride, salt. Okay, normal salt we have in the kitchen. So what happens when I add some salts in the water, the density of the water increases, and now the same egg is floating. So I believe that you know this experiment. And what I'm going to do now, it's another. So here I also have water. Let's see if you can see. So I have water with salt. And you can see that, oops, let me just, that it's floating, okay? So, the egg is floating with water and salt. And now, I will take this. And the question is, if I add now tap water, what happens? Because we know a fresh egg in salt water will float, in fresh water will sink, but if I add now tap water, normal water, on top of this salty water, I will do very slowly. And slowly, because I don't want them, oops, I don't want them to mix. Because the salt water is more dense, will stay on the bottom and the fresh water on the top. Sometimes I have a video with this experiment and you can see easily 2 layers with the salty water and the fresh water. And now I'm going to put the egg inside, and if everything goes well, the egg stays in the middle. And we can think, okay, yeah, stay in the middle, why? So if I take now, I pick this, and I mix the water, let's just take the fresh egg now, and now if I mix the 2 layers of water, we could think, yeah, the egg should be in the middle again. Let's see. Well, goes down. I think it's because the quantity of water that I add. Because if I probably put too much tap water, because I should put a little bit less. If I do that, the egg will float. And this is also a nice thing to ask the kids why. And if you put different quantities, volumes of water, of tap water or salty water, and see the difference after you mix. It's just to start questioning and talk about density. And also the kids can calculate the density of an egg. You can say, okay, I want to know the density of this egg. What can I do? And they have to find a solution. So determine the mass of the egg and then the volume. So I think it's also a nice activity to do with the kids. And another question is, okay, I add some salt to increase the density of the water. And if I add sugar, would have the same result? Yes, I will have the same result. But why don't we use sugar and we use salt? Because sugar, it's much more expensive than salt. I was looking, and I think a package of salt, 1 kilogram in Portugal, is 25 cents, and 1 kilogram of sugar is more or less €1, depending on the brand, but it's more or less. So the salt, and the kids can do the calculation, okay? So the salt is 4 times less expensive than the sugar. Okay. So the last experiment, let me see, where do I have? Okay. I'm going to use not a fresh egg, but a chocolate egg. This chocolate egg is flat on this side and is curved on this part. And I have a candle. This is not very easy to show live, but I will try. And we can investigate fluid dynamic. We can investigate Coanda effect and Bernoulli effect with this. So what I'm going to do, I will. Let's see. Okay, I have here the candle. I hope everything goes well. And I'm going to, this part is the flat part. I will blow and look to the flame. Okay, thank you. Sorry, I need help with an English. I'm going to blow. I don't know if you can see. Like this. The flame is moving towards me, towards me. And why? Because when I blow in this part, let me just, okay, when I blow here, what happens is that the pressure, the air pressure decrease in this part, and so the flame moves towards this side. Okay. And now you also can turn this like this. And now I have the round part, the round shape of the chocolate egg towards me. I will learn this word in the end of this webinar, towards me, and I will blow. Oh, it's not helping. Done. What happened here is the Coanda effect, and the air clings here. So it goes around, and I don't know the word, clings, I think it's the one. So the air going here, turn and go directly to the flame and blows the flame. Yeah, thank you. David, I think you have another experiment.
Right, so there. So this is the answer. So what would happen when I hit this as hard as I can? The two balls here. Where have they gone? One's hit. No, it's not a toy island. Alright. 2 balls fly up in the air, and the eggs are perfect. No cracks or anything in them, and they're all good. Okay.
So if you want to do that experiment, piece of wood, suggest you put little holes, just indentations in the ends, so the oops, be careful, will bounce neatly on the you can see that easier with so it bounces easily on the eggs. You can then put table tennis balls above and so on. Where we missed out, I'll just go back so we've covered everything. Unfortunately, my hard-boiled egg got rather bashed when the beaker fell over. But how do you tell the difference between a hard-boiled egg and a fresh egg? Take a fresh egg and spin it and stop, and it keeps going. Spin it, stop, see it keeps rotating. Stop, and it keeps rotating. Stop, and it keeps rotating. Stop, and it gets rotating again. If you use a hard-boiled egg, sorry, this is a bit cracked. Spin, spin, stop. It stays at rest because inside the fresh egg, there is liquid, so it keeps going when you stop it. And another one that I just sort of throw in for good measure, which is an interesting one to talk. 2 eggs, 2 chocolate eggs, 1 small, 1 large. If I drop them together, which one will reach the ground first? Which one gets to the ground first? Let's try it. I've got a hard surface so you can hear. Ready? Make sure your part is together, and just 1 bang when they hit the ground. So they arrive together. The small egg, small force down, the large egg, larger force down. So it's counteracted with the mass. A lot of these experiments we have online already in the What Happens Next Facebook pages, but we're putting them together in a set with a few extra videos to show different eggs experiments. We've taken them from the food and cooking booklets. That's the one that's particularly to do with eggs. You can see there's a whole series at the back.
Just I post in the chat the link of a playlist with all the experiments we showed today and more, and I will update with more activities, and also show that we don't have only the chocolate egg or the chicken egg. We have also these very small ones that we can do the experiment and see if it's the same. A quail egg, an ostrich egg, and of course the chocolate and the chicken. And also the kids can measure, like if you have small kids and you want to engage them in doing some measurements, they can measure the mass and see how much how much bigger is this one, and they can measure the height around yes, that's it. Okay, thank you. Bye bye. Happy Easter.
Goodbye, everybody.